Hi everyone, welcome back to the MATLAB Crash Course series. I'm Stephen Yagmore. So today we are actually going to take a look into vectors and matrices in MATLAB. So just the topics we're going to cover. First we're going to start with the nomenclature of matrices and vectors and just definitions. Then we're going to look at creating vectors in MATLAB. Then we're going to look at creating matrices in MATLAB. So first, just some definitions. So a vector. A vector is a structure that can hold multiple numbers in either a single row or a single column. So off to the right here we have some examples for people that have perhaps taken physics, calculus, Calc 3, vector calculus. Any of that, you'll be familiar with this. For those that haven't taken this, vectors are essentially a structure that can hold multiple different numbers in there. And a vector will either have a single row or single column. B, for example, here is a row vector because it's all in one row, 4, 47, 89. And A is a column vector, 1, 33, 445, and 89. Vectors are commonly utilized in MATLAB to store multiple numbers under a single variable. Instead of, say, saving each of these numbers as a separate variable, say O, X, Y, Z, W, instead we can save them all as one variable, which makes it a lot easier for us to access. We can store all of them as just the variable A, for example. Next we have a matrix. A matrix is a structure that can hold multiple numbers in multiple rows and multiple columns. So we can see here, for example, this is a little bit different than, say, a vector. A matrix, as we have here, it's not just one row or one column. We have multiple different rows and multiple different columns. A square matrix in particular is a matrix with an equal number of rows and columns. So this example over here is a square matrix because there are 4 rows and 4 columns. 4 equals 4. So it's a square matrix, or like a 3 by 3 matrix or 5 by 5. Those are all square matrices. Let's say if we got rid of this last column here and it was 4 rows and 3 columns, that would not be a square matrix. Elements can be referenced by their location through row and column. Just like an n by m matrix. So like, for example, once again, if I were to cover up that last column, this would be a 4 by 3 matrix because there are 4 rows, 3 columns. This is a 4 by 4 matrix. And you can reference a single element based on the row and column. So for example, if I wanted to locate, say, this 11 right here, I would say, okay, first this 11 is in the second row, and it's in the second column. So its position is 2, 2. It's in the second row and second column. That's how you would locate an element. Storing any number in a matrix can allow for more organization between those numbers. So for example, it's just more of a convenient way. Say, instead of having a giant single vector of multiple numbers, it might be more convenient to store them in multiple rows and multiple columns, as you might see in the future. The last definition I'm going to look at today is the transpose. The transpose of a matrix is an operation which allows all the rows of a matrix to become the columns and all of the columns of the matrix to become rows. This is a really common thing to do in linear algebra or mathematics. In algebra, you may have had to work with this. But you can see here, say, take this 3 by 2 matrix, 3 rows, 2 columns, 4, 7, 8, 3, 2, 9, and we want to take the transpose of it. Taking the transpose of a matrix, most likely in mathematics, is commonly represented by a capital T in the superscript, as you can see right here. So putting that T up there means, hey, we're going to take the transpose of this matrix here. And the transpose is going to look like this. And the way we get that is by turning the columns into rows. So here, the first column is 4, 8, 2. That's going to become the first row of our new matrix, 4, 8, 2. The second column is 7, 3, 9, and that's going to be our second row, 7, 3, 9. So the transpose can be easily taken by switching, just simply flipping the rows and the columns in a matrix. All right, now we're going to look at creating vectors in MATLAB. So a row vector can be assigned as a variable in MATLAB by listing a series of numbers separated by either spaces or commas in whitespace. So that might be a little hard to understand just by me saying it, but the easiest way to do it is by looking at some examples. So let's look at this here. So we're saying vec1 equals 4, 9, 2, or vec1 equals 4, 9, 2. We'll create a row vector with the values 4, 9, and 2. So let's open up MATLAB here. Got a little bit of work. Let's clear our variables and clear the command window. So like we said here, we're going to say vec1 equals, and then you'll put an opening bracket, and you can simply put 4, 9, 2. And when you close the bracket and click enter, it's going to turn out like this. Now we can see there aren't any brackets in our final answer here, but you can see it's a single row of integers, 492. That's a row vector in this case. It's a row of integers. We could say the exact same thing if we said vec1 equals 4, 9, 2. And that's going to give us the exact same thing. Commas or white space, either or, is not going to make a difference. Either commas or spaces will give you the same result. A column vector can be created by listing a series of numbers separated by semicolons, as opposed to commas or white space as we saw with the row vector. If we use semicolons to separate it, it will create a column vector. So look here, vec2 equals 5 semicolon 6 semicolon 1. That's going to create a column vector with the values 5, 6, and 1. So let's actually try that in this case. Let's say vec2 equals 5 semicolon 6 semicolon 1. And we can see it created a column of numbers, a column vector, just as we saw. Instead, we had to separate them with semicolons. The final thing we'll look at right here, column vectors can also be created by taking the transpose of a row vector. The transpose of a vector matrix in MATLAB is accomplished by placing an apostrophe after the vector. So let's look at one example. So let's look at our row vector we had. It was called vec1. So vec1 was a row vector. And if we were to take vec1 and place an apostrophe after it, let's see what happens. What it does is it takes our row vector and takes the transpose of it. The transpose of a row vector is simply its column vector because the rows become columns. So that's exactly what it's going to look like here. It's going to be the column vector 492. We can also place an apostrophe after a matrix in brackets or vector in brackets. So we can say vec3 equals 3, 2, 1 with an apostrophe after. This will create the column vector with values 3, 2, and 1. So if I were to say vec3 equals 3, 2, 1, so this would be a row vector normally if I were to just press enter now. But if I put an apostrophe after, that's going to take the transpose of the row vector, giving me the column vector with values 3, 2, and 1. So taking a little bit more about different ways to create some vectors, a few more unique ways. So vectors that have even spacing, such as say 1, 2, 3, 4, this vector right here, this row vector has even spacing. Each element is separated by 1. This can be created conveniently by using colons in the assignment. Let's look at a few examples here. For vectors of integers with spacing of 1 between each number, place a single colon between the starting and ending number. So let's say we want to make this vector here, 4, 5, 6, 7, 8, 9. One way you could do this, I'm going to clear my variables and clear the command window here. I could say vec equals 4, 5, 6, 7, 8, 9. I could type all that out and click enter, and that would be accomplished just fine. But there's a much more convenient way I could get to that same result. If I were to instead type vec equals, and then let's look at the slide to see exactly. So it's going to say vec equals 4, 9. You take your starting number, you take your ending number, and you put a colon between the two. Let's try that. We can say 4, 9. And this will give us the exact same result. We have a row vector of integers between 4 and 9. This is a lot more convenient, especially if you have a lot of different numbers that you need, and we're going to actually do an example of that later. For vectors with spacing of any other number between each number, use 2 colons with the format that follows. Starting number, colon, spacing, colon, ending number. So in this case, let's say you know your starting and ending number, but you want a specific spacing between each of those numbers. You can use this format here. Let's look at an example. Vec2 equals 3, 5, 18 creates the vector 3, 8, 13, 18. That means that the spacing between all these numbers is 5. 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. Let's do that example here. So we can say vec2 equals 3, 5, 18. We get exactly that. What were to happen if, say, I took the exact same assignment here, but instead I changed this last number to a 20. If I were to do this, let's see what the difference would be. Nothing would be different, and the reason why is because the last number can only be a number lower than the ending number given. So it's going to stop at 18 because the next number would be 23. But since 23 is greater than 20, the last number it cuts off at is 18. It won't go beyond the maximum number. If the spacing is unknown, but the number of elements needed is known, use the linspace function. And the way you do that is by typing linspace, and then in parentheses you put the starting number, comma, the ending number, comma, the number of elements. So this is useful if you don't know exactly what the spacing is, but we know how many elements we need. So let's look at this. Vec3 equals linspace 4, 20, 5. So this means we know our starting number is 4, our ending number is 20, and we want exactly 5 elements. It's going to look like this: 4, 8, 12, 16, 20. There are 5 elements with the correct starting and ending numbers. The spacing is instead 4. So this was a pretty easy one to see the spacing in between. Let's look at how we would do this. So vec3 equals, you type the word linspace 4, 20, 5. As you can see here, we get the exact result as follows. Once again, this is more common when you need to know exactly how many elements you want, but you don't know the spacing of it per se, or the spacing is not as obvious. So let's do a few examples just to see, just to test our knowledge here. So the first one here, create the row vector of all integers between 1 and 100. So let's see, how exactly will we do that? We want all the integers in between 1 and 100. If you remember what we talked about on the last slide, we have integers with a spacing of 1, so we can use the single colon notation to get every single integer between 1 and 100. Our starting number would be 1, our ending number would be 100. So we could simply make the assignment. We could say vec equals, let's lowercase that, vec equals 1, 100. This would actually do the job completely fine. This is exactly what we want. Let's say if I were to do exactly that in MATLAB, 1, 100, now this might look like a lot, and you might be saying, hey, we have multiple rows here. But so these aren't actually different rows of a matrix. This is still one long row vector. It just has to be split up along multiple lines because our command window it's too small to hold 100 numbers. As you can see here, we have 100 elements in a single row, going from 1 to 100, all the integers. This is exactly what we wanted to do. Second example here, create a column vector with 50 elements where the starting number is 7 and the ending element is 4,125. So let's see, so we know our starting element, we know our ending element. We don't have a spacing, but we do know how many elements we need. We need 50 elements. This means that we're going to use the linspace function that we talked about because we know how many elements we need. So let's just do this one directly in MATLAB. So let's see, we want vec equals linspace. So we know the first element was a 7. We know the second element, the ending element was 4,125, and we wanted exactly 50 elements. So let's enter that. So a couple things to look at here. First thing you might be asking, okay, well you said the first element was 7, but we have 0.007 here. Why is that? So the reason that is because that's not 0.007. That's actually 7. Because if you look up here, we have this little assignment here. It says 1.0 e plus 0.3, and then the multiplication symbol. That means that we're multiplying all of these numbers in here by 1 times 10 to the 10th, or in that case, 1,000. So you have to actually multiply each of these by 1,000 to get the actual number. So this number is not 7, it's 0.007 times 1,000, which is 7. As you can see, MATLAB just does that to save some space, to make it easier for those that are reading. And we do get to 4,125. So cool, we're completely done. But we're not, because this is a row vector, but our problem description said we needed a column vector with 50 elements. So what are we going to do in that case? Well, let's say we take the exact same function as before, linspace 7, 4125, 50. If we place an apostrophe after it, we're actually going to get what we want. Because remember, the apostrophe makes a transpose. It turns it into a column vector. So we get the answer we want by placing that apostrophe after it. All right, now we're going to look at creating matrices in MATLAB. A matrix can be assigned in MATLAB in a manner very similar to assigning a vector. We're going to use brackets just as before, and we're going to include numbers separated by spaces and commas for numbers in the same row, and by semicolons to start a new row. Look at this example here. So we say vec1 equals 753 semicolon 234. That'll create this matrix right here. 753 is going to be the first row. Then once you place a semicolon, we have to start a new row. So the new row will have elements 2, 3, 4, which is exactly what we see. So we can type this in MATLAB just to test it out. Let's clear that. So we can say vec1 equals, so we have 753, then we can place a semicolon, 2, 3, 4. If we close the brackets, we're going to get a matrix. Once again, there's no brackets in the answer that are going to show up, but you can see we have 2 rows, 3 columns, we have the matrix that we specified. If from the command line, one could also start a new row by pressing the Enter key. So instead of placing semicolons, you can actually press the Enter key to do the same thing. So let's say I could type the same thing. I could say vec equals 753, but instead of pressing the semicolon, if I press Enter, it's not going to do anything. But if I start typing my other numbers and then put the bracket, it's going to give me the same result. This is not as common. I'd recommend using the semicolon still, just because this will get a little wonky and it just doesn't look as nice. All right, a few other ways you can create matrices, but these are going to be random numbers that are going to be created as matrices. So the rand function, R-A-N-D, can be used to create a matrix of random decimal numbers between 0 and 1. So we can use the rand function as follows. So we can say vec equals rand3 to create a 3 by 3 matrix of these random decimals between 0 and 1. So let's see how the rand function, let's see what it's going to do. So I'm going to clear what we have. So I can say vec equals, and I can say, okay, so we want random, so we're going to use rand, and then 3. So you can see here, these are all random decimals between 0 and 1. And it's going to be a 3 by 3 matrix because we specified the 3 there. Vec equals rand 3, 2 creates a 3 by 2 matrix of random decimals. So if you enter 2 numbers in, not just 1, it's going to specify the rows and the columns. 3 rows, 2 columns. We could do exactly that again. I'm going to say rand 3, 2, and you can see the answer here is going to be 3 rows, 2 columns, decimals between 0 and 1. Exactly what we specified. The rand function, R-A-N-D-I, can be used to create random integer or a matrix of random integers. So this is a little bit different. The notation is a little bit different, but the idea is kind of the same. So rand in this case is going to be strictly integers. That's what the I after is for. It's going to be integers. So rand5 is going to return a random integer between 1 and 5 inclusive. So this isn't creating a square matrix like with rand. Like here we had a 3 by 3 matrix. But rand5 returns just a single number, a random integer between 1 and 5. Let's see it happen in action. So if I say rand5, I'm going to get a random integer. I got 2. If I were to type it again, I get 3. If I do it again, I get 1, again 4, again 2. It's completely random. MATLAB uses arbitrary pseudo-randomness techniques and the inner workings of it all to generate a random integer between 1 and 5 for you. This notation here, randy 10, 3, returns a 3 by 3 matrix of random integers between 1 and 10 inclusive. So in this case, we are actually going to make a matrix here. But once again, it's not like before with the rand function. In this case, the 10 represents our maximum integer value. We want a max of 10, a minimum of 1. And the 3 means it's going to be a 3 by 3 matrix. So once again, we could try this here. Randy 10, 3. We get 3 by 3 matrix of random integers between 1 and 10. It almost seems like we have all of them. 1, 2, 3. Oh, we don't have a 4 though. That's really interesting. I don't know if I've seen that before. So it's going to create a 3 by 3 matrix because we specified the 3, a max of 10 because of the 10. Look at the third example here. Randy, and in this case, we have a little vector. We have 2 values in for the first argument. We have Randy, and then in brackets, 5 space 17, comma 4. This is going to return a 4 by 4 matrix of random integers, but instead of the minimum being 1, we actually defined our new minimum integer. We're going to say that the minimum is 5 and the maximum is 17. So we can only return integers between 5 and 17. So let's do an example like that. We're going to say Randy, then we can say 5 space 17, close those brackets, and then put the 4 there. As you can see here, we have random integers, but the lowest one is 5 and the top one is going to be 17. We don't have anything less than 5, we don't have anything greater than 17, but we still had our 4x4 matrix because of the 4 specified. Right, last example, most complex, Randy, and then in brackets 2, 4, comma 3, comma 1. This is going to return a 3x1 matrix, so 3 rows, 1 column, of random integers between 2 and 4. We made our minimum 2 and our maximum 4. So the only values we can get are 2, 3, and 4. Let's do this one in MATLAB. 2, 4, 3, 1. So in this case, we happen to get all 2s in this case. But we did get a 3x1 matrix. If we were to do it again, we got 4, 3, 3. If we were to do it again, we got 2, 4, 3. We can only get 2, 3, and 4 in our values. We got a 3x1 matrix. And that's what the Randy function does in that case. All right, the last thing I'm going to cover with this lecture is going to be 2 other functions. We have the zeros function and the ones function. So the zeros function will create a matrix of strictly zeros with specified certain conditions that you may want. So zeros 4 will create a 4x4 matrix of zeros. It's fairly straightforward how it works. So if I were to say just simply zeros, and if I were to put 4, you can see I have a matrix of all zeros here. Or if I were to put zeros 30 even, I get a giant matrix, a giant square matrix, 30 by 30 matrix of all zeros. Might be asking, okay, when is this relevant at all? Well, perhaps you're making a board game and you want to identify the different pieces of chess on the board with different number. An empty space could be a 0. The way you'd want to start the board is by making a matrix of all zeros, for example. So the best way you'd want to do that is by saying, let's say it's a chessboard, an 8x8 chessboard, 0 is 8, it's going to give you an 8x8 board of zeros. And they can start filling in different numbers by there, which we'll actually talk about in the next video. The last topic is going to be the ones function. It does the exact same thing as the zeros function, but instead it puts ones in its place. Ones 2, actually I apologize, I skipped a certain section. Zeros 3, 5 will create a 3x5 matrix of 0. So if you enter 2 numbers, it gives you the row and column, kind of like similar with the rand function. So let's do that real quick. Zeros 3, 5. So this is not a square matrix anymore. Back to what I was saying about the ones function, same thing, same concept, it's ones instead of zeros. So ones 2 will create a 2x2 matrix of ones. So if I were to say ones and then 2, I get a 2x2 matrix of ones. Then if I were to say ones 4, 3, 4 rows, 3 columns of all ones. So say ones 4, 3. And that's exactly what we have here, the simple matrix. All right, so if you remember this video, we talked a bit about the nomenclature, the definitions, and then looking at how we create vectors and matrices in MATLAB. On the next lecture, I'm going to talk a bit about what we can do, how can we change these vectors and matrices, what can we index them, how can we modify them. That's going to be what we're going to look at next time. Thank you.